This video will go through how to control density calibration equations in Coral CT. So the button we'll use for that is from the homepage of Coral CT, here, CT density calibrations. When we click that, we get two options. One is to select a standard group. So these would be CT scans of multiple standards that have been scanned and added to the server and that we can use to develop a new density calibration equation. So we'll come back to that later in this video. First, we'll start with a simpler option of manually entering a density calibration equation if we know one externally. Okay, so we get this option where we can enter an equation in the form of Hounsfield units. HU equals density grams per cubic centimeter times the slope term plus an intercept. All right, so let's look at what we currently have for these for a particular core. I'm going to click out of Coral CT and go into the Finder. This is my working directory. So this is the folder that I chose at the startup of Coral CT. I then go into My Corals, and you might have some different files here, but you should have a Coral directory master. And I'll open that with Microsoft Excel. The columns that we're looking at are den slope and den intercept here. These are the density slope and intercept that converts Hounsfield units to density and vice versa. Okay, so I'm gonna, as an example, we're gonna look at core 53B that has what are used as the default terms. You can see more about where these come from in our instructional materials. So these are the defaults, but if we want to change them, that's what we're showing you how to do in this video. All right, we can't just change them in this Excel spreadsheet here and click Save because Coral CT is actually pulling this information that's in the spreadsheet from the server. All right, so we need to actually change these values on the server, not just locally on our computer, and the only way we can do that is in Coral CT. So I'll close this, go back to Coral CT, and it's by using these options here that we can change these values on the server. So I'm going to just put in some different numbers for that F53B core, just as an example. When I type the core name here, it has to be case sensitive, matching an exact core that's in the directory. If I put a different name, like this core doesn't exist, I'll get a warning message, invalid core name, and I won't be able to choose this button to add to the directory. Similarly, it has to be a core that you are either an owner on or is publicly accessible, fully publicly accessible for you to be able to change the density equation. Okay, valid core name, we put slope and intercept. Now I can update the equation in the directory. So if I click that, that's done. So we can check that here. It is also like re-downloaded locally, but because we did that through the server, it's also changed on the server. So these updated values would then be reflected in anyone else that's working on the F53B core. So we see updated equation there. Okay, so all that did was change those values in the directory, so then any future processing of growth rates from that core, the density column will reflect this new equation. But perhaps some output files have already been generated for that core, and now we're updating the equation, and we want the previous output files to reflect this new equation. In that case, we can use this checkbox here. Let's update output files for this core. And that will actually update those output files so that the density in grams per centimeter cubed reflects our new equation. So I'm actually going to change it back to the correct equation for this core. And now I'm going to check this box. So that will update the output files. Okay, so that's done. So I'm not going to show you the output files, but it would have updated all of them on the server. So if we were to use from the home screen to access data and downloaded output files for that particular core, they would now reflect whatever equation we just updated in here without having the need to like re-download the core and click process growth again. Okay, so that's how the manual entry works. So to do that, you would need to already know these slope and intercept terms on your own from some mechanism. So the other thing that we're going to go through now is how to use existing CT scans or to extract your own separated CT scans of standards and make a new equation. So I'll click Done with Calibration Equations here. We go back to the home screen of Coral CT. We'll go again to CT Density Calibrations. All right, so this is where we can select standard groups. So first I'll show you one that already exists, and then we'll go through the longer step of how you might make one if you have a CT scan that contains density standards in it. So let's work with one that we've already made. I'm going to choose this group here. Okay, and so now I see the options here to select the standard. So these are standards, the names of the standards that were submitted for this particular group. So as we'll see when we go through actually how to make this, this is something that you can control, named for whatever particular standards you've made on your own, or we do have sets that we loan out. Okay, so I'm going to choose this first one here. So I have this spreadsheet down here that we use to make these standards as the volume and the mass and the density is calculated from that. So I'm just going to enter the numbers here. And really probably 3 decimal places is sufficient. So I'll just round those a little bit. So as soon as I kind of click off of this box here, they get added to this table here. This table is kind of showing the values that are going to go into making the equation. Okay, and as soon as I add at least 2 values, then I can process the density calibration curve. That wouldn't be very good right now. Using just two standards is not ideal, but possible. But these are so close in density, that's not going to be a good option. So I'm going to keep adding the rest of these. It does not matter which order we add them in. Okay, so I added all 5 there. We see them there. I can now click the Process Density Calibration curve. So this takes a little while because it needs to actually download the CT scan of each of these cores from, or each of these standards from the server and calculate their average Hounsfield units. So this will take a little bit. Okay, so we can see that this calibration equation is finished. So this is the calibration line that we got, which is pretty good. Looks like there's a pretty strong, clear correlation between the density, known density, and Hounsfield units as we would expect. So this generates the equation for us here. So we could take this and manually apply it to cores as we just saw earlier in the video, but we're able to just do that right now based on this equation that's shown here. So if I wanted to apply this to a particular core, I could just enter the core name here. So if this applied to F53B, for example, I could put this here. Same deal as before. If we click this, it will update any output files that have been already generated for this particular core. I'm not going to press enter on this now, but we've already seen how that works. Okay, so I'm going to say done. I'm going to go back to the home screen. So that's how to use existing sets of standard scans that are already on the server. So now we can talk a little bit about how you might make your own group of standards. So you would have to have density standards. So we use ones that are pieces of coral core cut into nice cylinders that then we can readily measure the volume and the density of, and then we CT scan them. So I'm going to show you an example then of if we have a CT scan, how we would crop out each separate density standard and add it to the server. All right, so actually, I'm going to use the open last button here. Right, this particular core that's going to open includes both a coral core scan and density standards that I'm going to show how we could crop out to make a calibration curve. Okay, in this particular case, this is the core, and these are the standards. Okay, so I'm just opening it in the full view here to show you what we're working with. We don't actually need to open it this way, so I'm going to go back to the home screen. just to see there's 5 separate density standards in this scan. Okay, so we're back on the home screen. So that was just to show you what that scan looked like that had the different density standards inside of it. And we need to crop them out. So we have separate files for each of those density standards. Okay, so it also is useful that now in my current scan, this DICOMS folder contains the DICOM files. So the arrangement of folders is really important. We'll get to that shortly as we go. We're going to use the Submit or Edit Data button. There's a bunch of buttons here to do various types of file submissions, but first we need to modify the data because we need to crop out sections of that full CT scan. So there's a few different tools here. One we're going to use is the crop DICOMS. Okay, so I'm going to now navigate into my working directory and in current scan. So current scan contains those DICOMS. Okay, and so the instructions for this say to choose a folder that contains one or more subfolders containing DICOM files. So the way it's currently arranged, these are the DICOM files.dcm. They're in this folder, and this folder's inside of DICOMS. So in this current arrangement, I want to select DICOMS, right? Because that's a folder containing one or more subfolders containing DICOMS. It doesn't matter that there's some other files in here. It's only going to look for .dcm. So I'm on the right level here to say open. Okay, and then I can crop from different views. I'm going to start with the axial view. That'll be like a top-down, you could think of view, to just pull out the standards from the other core that was in that scan. Okay, so once it's finished loading, a window like this will open. And so this is showing like that top-down view. It's just kind of actually showing like the maximum intensity throughout the entire scan. So you can see where the core and the standards are. So you need to have an idea of what the orientation of your scan was and what's inside of it. So I know that this is the core that I'm not interested in. These are the standards. This is what I want. So I'm going to now draw a rectangle that will include the standards. And it's better to go a little bit big just to make sure I'm not excluding anything. So that should capture everything. And then it's now writing new files. So while that's going, we could look at the folder orientation again. So in DICOMS, that's the level that I selected. It read all of these files, minimize that, and the program is now making this folder cropped. So it's adding all of these right now. So we can see it's continually adding files. Okay, so that finished, so it completed the cropping, so all those DICOMs are now in this folder here. Okay, so now we're going to crop again. So now just this first part contains, I've excluded that core from, that was also in that CT scan, so I have just the standards, but I need to separate those standards into individual files. Okay, so now we need to be a little bit careful. So I'm going to do cropping again, so modify data, but before I click this button, we need to actually move some things around. Because as I said, we will select a folder that contains one or more subfolders containing DICOMs, and the app will read all the DICOMs in those subfolders. So as it is right now, it would actually read all the DICOMs in cropped and the original scan. So actually that would generate an error, or a really weird looking file would pop up. So we need to move this out somewhere. So I'll move this out here just into the kind of home page of my directory. But now I actually am going to need to make another folder, right? Because this is a folder containing DICOMs directly. So I'll make a new folder that can be named anything, but I'll just call it all standards. And I'm going to put the cropped folder, let's just rename this so it's not named cropped. Just call that DICOMs. Again, it could be named anything, although changing the name from cropped is a good idea. Okay, so I put that into all standards, and then DICOMs, and then those are the DICOM files containing all the standards together. So now I'm going to point CoralCT to all standards, because that's a folder containing a subfolder containing the DICOM files. So all standards. And now I'm going to crop from one of the side views, sagittal or coronal. In this case, it really doesn't matter. So I'll just do sagittal. You know, this should go a little bit faster now because we've cropped down to smaller file sizes. And back in our Finder, now I see within all standards, I have DICOMs. So that's the DICOMs of all the standards together. And I have this new folder cropped that's going to contain whatever files I choose to crop when the new window pops up in a second here. Okay, so the cropping window is now open and available. So I'll start, doesn't matter where I start, I'll just start down here. This is H5, so you need to know the orientation of your scan and know which standard is which. So I know which one this is. So these are quite close together, so I'll do as good a job as I can. I want to get the whole standard, right? I really want to get the whole volume for the most accurate results. And I don't want any of the volume of the other standards. So I'll choose right there. So you also do want to be careful when you're doing the CT scanning to have things in the right orientation where you can successfully crop out individual standards and that you know that orientation and which standard is which. All right, so now it's going to go quite fast because we're getting onto smaller file sizes now. All right, so that's already done. So now looking where we're at, now I have this folder cropped. So this I know is H51. So I want to just rename that. All right, and again, I need to move this because I'm going to do additional crops on all standards, and we need to have it be only this DICOMs folder that's in there, because otherwise it will read DICOMs in each of these subfolders, right? So I need to take this, and I can just put it out in like the main part of my working directory for now. I can come back and reorganize that later, but for now this will work, that I can now do cropping again to get the next standard. All standards. All right, I'm going to crop the next standard here. All right, as that's just finishing up, we'll go into the Finder. So now this cropped folder that just finished is now H61. Rename that, move it outside of the all standards folder, and continue. So I'm going to skip doing the rest of the standards. You should get the idea from these two that I did. And then the last steps to this would be to submit these. So I actually need to zip them all. So I'm just going into H6.1 and Command A to select all and compress. And you have to rename this to dicoms.zip. All right, you can also just zip this folder, although I would suggest to do it the way that I just did, where you actually select all of the .dcm, zip that, or compress it into a .zip and rename it dicoms.zip. And once you have that, so it doesn't contain the name H61, but it's in the H61 folder. So that's a good way to make sure that you stay organized, keeping this in this folder. And then to submit it, you'll use the direct submission button. And so there's a separate video walking through how to do that. So if this is what you're doing, go see that other video to complete the steps. And once you actually finish doing the direct submission, then you'll be able to go to the CT density calibrations, and you will find your group here. So you'll be able to name a group that will contain whatever standards. The group name could be anything, and it'll contain the standards that you submit associated with that, and you'll be able to follow the instructions that we already went through in this video to make your own calibration curve.